In this video, I will show you the experiments to produce the output of AC 230 volt from car's alternator. This faulty of no charging alternator has DC 12 volt and 130 amperes capacity. For disassembling alternator, undo 4 long bolts here. Then pulling the pulley with rotor together out from the main body. Here are the components separated from that alternator. I have found a faulty regulator which is here. What I am going to do, instead of hooking wires involved to test regulator here, I have an idea and modify this regulator to let it work again for testing purpose. I have done so such as bypass the faulty part of regulator, which soldered 2 wires to each brush. The one is for positive and the other is for negative. Now the modified regulator is fixed to its position. Yellow wire is for a brush at front, and black wire is for a brush at rear. There are the wires have been installed to the components here. Alternator's rotor. Stator with 4 heavy-duty wires installed. Rectifier and regulator assembly. This wire has been connected to the one of modified regulator's terminal. The end here will be connected to battery's positive terminal. 2 wires of these have been connected to the points, where they are just before rectifier's diodes from stator's coil 1. The way of these wires connected from coil 2 is the same as coil 1. The output from each pair of wires is the same value, and AC voltage of course. The 2 wires can be connected from any 2 of 3 ring terminals. Coil 1 and coil 2 are separated. This is a DIY rear bracket and 2 front brackets installed. These are the wires from coil 1. And the coil 2's wires are here, which are not be used for this experience. The end of wires insulated and wrap them around here instead. This is the wire which connected the one of regulator's terminal to excite alternator's rotor. The things here have been set up for the basic testing. This is a switch, which is connected between battery's positive terminal and the excited wire, for switching the battery on or off for excited alternator's rotor. That is a metal bridge rectifier, using it as a diode with large capacity. It is connected between alternator's DC positive output terminal and the excited wire. Turn the switch off manually as soon as alternator has the DC output. This small bulb will indicate the level of alternator's DC output. That black wire from battery's negative terminal is connected to alternator's body, which also means alternator's negative or ground. A car bulb is there as a load for alternator's AC output. And a multimeter is there to measure the AC output as well. An electric drill will be used to turn this pulley fast enough to have the power generated from the alternator. A speed controller can be used to adjust the drill speed, so the alternator's output will be adjustable. Started the drill engaged with alternator's pulley. Almost at the same time turned the switch on. Then had been turned it off by a hand. No sooner bulbs were on. The speed controller had been adjusted to maximum. The output voltage were from AC 5 volt to 9.8 volt, indicated by the multimeter. The drill's maximum speed is 1,800 revolution per minute, But the alternator's normal speed is about 5,500 revolution per minute. That was reason for the alternator's output of AC 9.8 volt. Never mind. With this condition, things have been set up here. The parts here are connected just like previously. This is a DIY up transformer with ratio of 34.3. The low voltage side is primary, which has been connected to the alternator's AC output terminals. The transformer's secondary has been connected to 3 globes, as its load. A multimeter connected to secondary as well, to measure AC voltage across its terminals. Hand on a second. Make sure red and black wires have been connected to battery's terminals correctly. After correction and double-checked, everything is alright. This is driven by the drill's maximum speed of 1,800 revolutions per minute. The output AC is 226 volt with the load, measured by a multimeter. An 18-watt fan is connected to the output with 3 globes together, and total load is nearly 100 watt. A fan and globes worked very well. An AC 215 volt was indicated by the multimeter. Although the alternator didn't reach its normal working potential because of its low revolution per minute. From these experiments we can see. This is a DIY transformer with 500 watt capacity. And 2 wires here also are available to connect another transformer. By using a way to turn the alternator at a speed of 5,500 RPM, and 2 modified transformers connected, it were possible to produce and supply a combination of 1000 watt AC 230 volt power and 500 watt DC 12 volt power at the same time. This is the circuit's diagram for the components connection, and the experiment has been done. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.